Okay, moving right along here. Number 12. Integral of arc sine x dx. All right, so this one is just like the one we did before. We don't have a whole lot of choices for our integration by parts table. So I'm going to go with u being the arc sine of x and then dv being dx. And remember from previous sections, the derivative of arc sine is 1 over the square root of 1 minus x squared. And that is actually formula on your derivatives reference page 5. It's formula number 19. So there's my derivative. And then v is the antiderivative of dx, which is just x. So we've got ultraviolet x sine, or arc sine x, minus integral voodoo, which is this times this. So that x I'm just going to put on the top. X over square root 1 minus x squared dx. And this is actually good because now I can use a basic substitution. I'm going to let u be equal to the whole thing underneath the radical. The derivative of that is negative 2x dx. I have an x dx, so I just scale this. Negative 1/2 du is equal to x dx. And now I just rewrite this. This integral now becomes integral. The x dx is the negative 1/2 du. So here it is, negative 1/2 du. And then I have, remember the x is already gone over here. I have 1 over this, so 1 over the square root of, but this whole thing is u. So this is the same as negative 1/2 integral u to the negative 1/2 du. And that's just square root of u is u to the 1/2, and then bring it up. And now we just use power rule. So I have negative 1/2, and then I'm going to leave a space. U to the, I add 1 to that, I get 1/2. 1 over 1/2 in front is a 2. And then I'll have a constant. But this is going to be just equal to, the 2's cancel, negative square root of u, which for me is negative square root of this, 1 minus x squared, square root of 1 minus x squared. So this whole integral becomes this. And so my final answer is going to be this piece here, x, arc sine, x, and then minus this, but there's 2 negatives there, so plus square root 1 minus x squared, plus some constant. And that's it. All right, number 13. All right, 13 is a really important problem. Integral e to the 2 theta sine 3 theta. E to the 2 theta sine 3 theta d theta. So this problem is different than everything we've done up to this point. And this is definitely one of those problems that I like to give on tests because it's kind of a different technique for this. I mean, it's still integration by parts, but nothing's going to ever go away and become nice. And I did one like this in class. So let's see. If I choose my u to be this, we know the derivative of that is itself. And there's some constants there, but it's always going to be e to the 2 theta, e to the 2 theta, no matter how many times I do integration by parts. This one, if I use this as my u, then it's going to be sine and then cosine and sine and cosine. So there's no way to make that go away. So there's no easy way to make either one of them go away with integration by parts. However, what we're going to do is we're going to hope that when we do our integration by parts, we're going to get this integral to appear on the other side. And once we do, we'll bring it back to this side and we'll work out the answer. So let's see how this is going to go. I'm going to choose my u to be, I'm just going to let it be the e to the 2 theta. And that forces me to let my dv be everything else, sine 3 theta d theta. Now, derivative here, du, is going to be itself, but then times the derivative of what's up there. So 2e to the 2 theta d theta. The antiderivative here is negative 1/3 cosine theta. So right now we have that this is equal to ultraviolet, this times this, negative 1/3 e to the 2 theta cosine 3 theta minus integral voodoo, which is this times this. Now I'm going to try and do this in one step. I'm going to have a negative 1/3 times 2, so that's negative 2/3. I'm going to bring that out, and so that's going to make that a plus 2/3 integral, and then everything else, the cosine theta, and then the e to the 2 theta d theta. So e to the 2 theta cosine 3 theta d theta. Now this integral is still something I can't do. Nothing's really gotten better. I have a cosine here instead of a sine. So what I'm going to try and do is integration by parts again, so that when the next time I do it, I'm actually going to get this integral to appear on this side. So I'm going to make the same substitution I just made. And remember, I'm just working on this part right here. So u is going to be e to the 2 theta. The derivative of this is 2e to the 2 theta d theta. We did that already over there. dv is what was here, so cosine 3 theta d theta. And then the antiderivative is going to be 1/3 sine 3 theta. All right, so now I'm going to rewrite this. What I have is that, and because this problem is unique, I'm going to rewrite everything here. So I have integral e to the 2 theta sine 3 theta d theta is equal to this piece here, negative 1/3 e to the 2 theta cosine 3 theta plus 2/3 times, now my integration by parts, ultraviolet minus voodoo. This times this, so 1/3 e to the 2 theta sine of 3 theta, so there's ultraviolet, minus integral voodoo, so this times this. And again, I have the 1/3 times the 2, I'm going to bring that out as a 2/3, and then it's just going to be the e to the 2 theta, and then the sine 3 theta d theta, and then let's close my brackets. So look what I have. The integral I'm trying to figure out has actually appeared again exactly on the other side with some different constants. So what I'm going to do is first break this out of the brackets by distributing a 2/3 through. And then I'll write all of that up here. So I write this here, I write this here, and then I'll just continue right here. So I don't have to rewrite the whole thing. This is all gone. Okay, let me see. Do this. So that's up to here, and then now distribute through. That's going to be 2/9, and then this expression, e to the 2 theta sine 3 theta, and then this times this, negative 4/9, and then this integral. Integral e to the 2 theta sine 3 theta d theta. All right, so that's what we get when we distribute through. Now what I'll do is I'm just going to use, properties of equations here to say that I can add or subtract anything from both sides. So I'm going to take this integral right here. Since it's minus 4/9, I'm going to add 4/9 of this integral, and I don't know what that integral is. And add it to this side, so they're going to cancel out completely. But what I do to that side, I have to do to this side. Remember, there's a 1 in front of that. So these canceled, right? These are gone. But over here, you have one of these plus 4/9 of these. So 1 plus 4/9 is what, 13/9? So we have 13/9 of this integral. Okay, equals -1/3 e to the 2 theta cosine 3 theta plus 2/9 e to the 2 theta sine 3 theta. And I'm going to try and get this integral by itself with a 1 in front of it. So I'm just going to multiply both sides by 9/13, just this flipped over. So if I multiply this side times 9/13, this becomes a 1. And I have to multiply this entire side by the same thing, 9/13. And that will distribute through to the constants like this. And so we should be at our final answer. So our final answer will be that one of these integrals is equal to, okay, we multiply here, 9/13 times this. So 9 times -1 gives me -9 over 13 times 3 is 39. And then I distribute the 9/13 here. 9 times 2 is 18. So this is going to become 18 over 9 times 13 is 90 plus 27. I can't do simple math right now. 90 plus 27. Why can't I do simple math right now? 117. All right, so 13 times 9. And then that piece. And then everything else is gone. And we are there. Let's just remember we need to add a constant of integration. We have isolated the integrand again, or the integral we wanted is here by itself, and we have it's equal to something, and that is the antiderivative. So what number was this? This was number 13. I'm actually going to look at the back. Oh, I don't have the answer, but I'll double check it in the solutions and see, make sure it worked out. So that's a good one. Okay, next one. Very similar problem. Number 14. Integral e to the negative theta cosine 2 theta d theta. All right. So here, we do the exact same thing we did on the other problem. Because I know if I take derivatives of e, it's never going to go away. And if I take derivative of cosine, it's going to keep switching back. So I'm never going to get it to vanish out. So let's go ahead and set up our table. U is equal to e to the negative theta. dv is everything that's still here, cosine 2 theta d theta. The derivative of u is negative e to the negative theta d theta. And that's because derivative of e to the negative theta is itself, but then derivative of negative theta is -1. Antiderivative here, okay, accounting for that 2 in there, we have 1/2 sine 2 theta. So we get ultraviolet. So this times that, 1/2 e to the negative theta sine 2 theta minus integral voodoo. So this times this, I have a negative, I have a half, I'm going to bring that out, but this is already a minus, so plus 1/2 integral, and now just the sine 2 theta and the e to the negative theta d theta. So I'm going to write that as e to the negative theta sine 2 theta d theta. So notice this integral here does not match this one, but it's close. So what I'll do is I'll do integration by parts again. Let me do it over here so I can have some space over there. So I'm doing integration by parts again. I'm doing it just on this piece. right here. So I'm going to let u be the same thing it was here. U is equal to e to the negative theta. Du is equal to negative e to the negative theta d theta. This time my dv is going to be sine 2 theta d theta. And when I integrate, I get negative 1/2 cosine 2 theta. And so here's what I've got. This is equal to 1/2 e to the negative theta sine 2 theta plus 1/2, and now bracket, here's my new ultraviolet minus voodoo. Ultraviolet, this times this, so negative 1/2 e to the negative theta cosine 2 theta, then minus integral voodoo. But remember, when I do my minus here, look what happens here. Negative and negative is positive, but I'm subtracting it, and then I have the 1/2. So I'm going to bring that 1/2 out. And then I have e to the negative theta cosine 2 theta d theta. And I know I'm close to going off the board there. I think I fit that in. Okay. Oh, close my brackets. All right, so what I'll do now is notice that the integral I'm looking for right here is now appearing over here, but I need to release it from the bracket, so I need to distribute that 1/2 through. So I'll do that on the next line, and I'm actually going to cheat again. I'm going to just reuse what I have up here already. Okay. So this is this plus, oh, actually it's going to become a minus. So minus 1/4, and then e to the negative theta cosine 2 theta. And I've been using parentheses, so I'll use them again. And then 1/2 times that is going to be negative 1/4 integral e to the negative theta cosine 2 theta d theta. So I've released it from the brackets. And by doing that, I'm actually allowed now to move it to the other side. So I will add to both sides. Yes, I'll add 1/4 of this integral. Whatever it is, I don't know what it is yet. And they'll cancel over here. But if I do that over here, I have to add it over here. Add 1/4 integral e to the negative theta cosine 2 theta d theta. And so when I take one of these and I add 1/4, I have 5/4. So 5/4 of this integral e to the negative theta cosine 2 theta d theta will be equal to all of this. 1/2 e to the negative theta sine 2 theta minus 1/4 e to the negative theta cosine 2 theta. And then this canceled out. And remember, you're going to have a constant integration. You can put it in at the very end. I'm just going to put it here now. And then I'm going to get rid of the 5/4 here. I'm going to multiply by the reciprocal. So I'm multiply 4/5 here. And then this will become a 1. And I have to do 4/5 on this side. And I'll put 4/5 out here. It doesn't matter if I multiply c times 4/5 because it's still a constant. I don't know what it is. So I'll distribute through here now. So when I distribute 4/5 to here, I get 4/10. So again, I'm going to cheat. I'm going to just erase this. 4/10. Oh, 4/10 is 2/5. And then I distribute here to here. And when I do that, I get 4/20ths, but that's the same as 1/5. So minus 1/5. And I've distributed, so I don't need this anymore. And I have my constant of integration. So, oh, and this side becomes a 1, so it's just this. So that's it. This is your antiderivative right here. all of that. All right, number 15. About halfway through here. Okay, so number 15, integral x e to the 2x on top over, in parentheses, 1 plus 2x quantity squared. All right. So really on this one, you're trying to figure out what you can use. Well, if you're going to use integration by parts, what are you going to choose for u? What's du? Is it obvious? There's almost like three things here. It's like an x, then times this, so that you could choose one of those to be your u, but then you have divided by this. So you actually have three things. Forgot my dx. So it's not so obvious how to choose your u. Remember that whatever you choose for your u, the other part you need to be able to integrate. So you look at this for a while, and I don't know, if you had just this squared, like 1 over the 1 plus 2x squared dx, if you had that as an integral, we could integrate this using a basic substitution. So I know I can integrate that, which means I could choose this to be my u. Let's see what happens if we do that. So no promises that this is going to work. Let's see. I let my u be x e to the 2x. I let my dv be everything else, which was 1 over 1 plus 2x squared dx, because I know I can integrate that. Now let's check out this derivative, because this derivative is really going to be helping me determine whether or not I want to stick with this or not. So du is going to be product rule here. So derivative of the first one, 1 times the second, plus the derivative of the second one, which is itself, times the derivative of what's up here, which is 2, times the first one. So e to the 2x times the 2 times the x, and all of that dx. All of that dx. That looks really ugly. I don't know if I'm going to want to voodoo this thing, but let's see what this does. So when I integrate that, remember, this is what I'm doing. I can make a basic little substitution. U is the bottom. Du is 2 dx. I don't have a 2 dx, I have a 1 dx, so 1/2 du equals dx. So I can rewrite this integral as 1/2 and then 1 over u squared, 1 over u squared, which is u to the negative 2, and then the du. And then the antiderivative of this, we just add 1 to the power. This should be negative 1/2 u to the negative 1, which is really negative 1/2 times 1 over 1 plus 2x. So that's what I would get there. So let me throw that in here and see if I want to mess with that or not. Negative 1/2 times 1 over 1 plus 2x. And right now you look at that and you're like, oh my God. I mean, ultraviolet, fine, we write that down. But voodoo, do I really want to mess with that? That voodoo looks terrible. Until you realize that on this du, they both have e to the 2x in them. So factor out an e to the 2x. What you'd be left with is a 1 here, plus over here you have just 2x, and then dx. And check this out. This, when you multiply this times this 1 plus 2x and this 1 plus 2x will cancel. I mean, the only way you know this is actually try it. I mean, it's not obvious from up here that this is going to work. So let me write it all out. I've got equals ultraviolet, this times this. Negative 1/2, because I like to put my constants first. Then all of this, x e to the 2x times this, 1 over 1 plus 2x, minus integral voodoo. So when I do my voodoo, it's going to be this times this. I'm going to write it all out. The negative 1/2 I'm going to pull out and make it a plus because it's already minus here. So that's plus 1/2. So that 1/2's gone. Let me write all this down and then I'll put this next to it. So e to the 2x, 1 plus 2x times 1 over 1 plus 2x dx. So that's everything. That's voodoo written out. And this one cancel. Isn't that great? Once you get that, this integral becomes, let me see. So this is equal to negative 1/2. I'll write it like this. X e to the 2x over 1 plus 2x plus 1/2 integral of e to the 2x dx. And that is easy to integrate. So we get negative 1/2 x e to the 2x over, this is multiplication, 1 plus 2x plus, okay, antiderivative of this is going to give us 1/2 e to the 2x plus a constant. And so we put those together and we get 1/4. Now I'm going to clean this up because I don't like the way that looks. So I'm going to put just the negative up top. So negative x e to the 2x over, I'm going to distribute the 2 through. So 2 plus 4x. And then plus 1/4 e to the 2x plus c. There we go. And if you take the derivative of this, you should get that. Quite the mess, quite the mess. These are getting harder as we go. This was not obvious at all to use that. If you choose a different u on that problem, you may be here for a while. Or I should say, if you choose a different u and a dv, that could really hang you up. All right. T cubed e to the t dt. 16. T cubed e to the t dt. Is that right? This problem seems to be a little bit too easy. Well, let's see what happens. So I know that if I take derivatives of t cubed, keep doing it, it's going to get lower and lower powers of t. And then antiderivatives of e to the t is just itself. So it looks like I'm going to be doing integration by parts several times here. So in my first one, let u be equal to t cubed. dv is then e to the t dt. Du is 3t squared dt. And v is e to the t. So integrating. So this should be ultraviolet. T cubed e to the t minus 3 integral t squared e to the t dt. So all I did was voodoo here. I took the 3 here and I brought it out. I had the t squared e to the t dt. And now notice the power came down on this, so it very much looks like this. So I'll do another integration by parts. Just this piece right here, integration by parts on that. And I'll do my table over here. U is going to be equal to t squared. dv is e to the t dt. du is 2t dt. v is e to the t. So we have that this is equal to t cubed e to the t minus 3, and then in brackets, ultraviolet minus voodoo. T squared e to the t minus integral voodoo. Here times this, the 2 comes out, and then I have voodoo, t e to the t dt. And let me go ahead and distribute the negative 3 through so I can get those brackets out of there. T cubed e to the t minus 3t squared e to the t. So that was from here to here. Now here to here I get plus 6 integral t e to the t dt. And now I'm going to go one more time with integration by parts on this piece right here. And I'll do that table right here. U is equal to t. dv is e to the t dt. This should be my last one, because when I take the derivative of u, I just get dt. And then v here is e to the t. So everything is a repeat of what we've been doing, except the powers on t keep coming down. So this becomes t cubed e to the t minus 3t squared e to the t plus 6 bracket, now ultraviolet minus voodoo. Ultraviolet, we're going off this table right here. Let me get this one out of here so I don't accidentally look at it. So that one up there, we're doing t e to the t minus integral voodoo. Voodoo is just this right here. So it's just integral e to the t dt. And I'm done there. And that's it. I can integrate this. The antiderivative of this is just e to the t. So we get as a final result t cubed e to the t minus 3t squared e to the t. Now distribute the 6 through, plus 6t e to the t. The antiderivative, okay, so this right here is e to the t, plus a constant. So I'll distribute the 6 through. I'll get negative 6 e to the t plus some constant. Just be aware that that 6 had to come through this bracket. And that's it. This is your antiderivative right there. You could factor out an e to the t if you want, but that's good enough. All right, 17. Okay, so this is the first one that has the definite integral, but we're not doing definite integrals in here. So in the problem in the homework assignment, it has numbers here, and I'm saying to ignore those for now. We've got x cosine pi x. dx. So this one, all I need to realize is that if I let this be u, the derivative of that is going to be a 1 or a dx. And I can find the antiderivative of that. So this one is actually kind of easier than the one we just did, because it's just a very basic one-time thing, one application of integration by parts, and we should be done. dv is cosine pi x dx. Derivative here is dx. Antiderivative here, negative 1 over pi sine. Oh, not negative. I don't know why I did that. Antiderivative of cosine is sine. So sine pi x. So this becomes ultraviolet 1 over pi x sine pi x minus integral voodoo, which is across like this. And I pull that 1 over pi out, and I have sine pi x dx. And then the antiderivative of sine pi x is negative cosine. So we have equals 1 over pi x sine pi x. And then we have minus 1 over pi times, now again, antiderivative of sine is negative cosine, but I have to account for that pi. So negative 1 over pi cosine pi x plus c. So 1 over pi x sine pi x plus, because negative times negative, 1 over pi squared cosine pi x plus c. Okay, number 18. integral x squared plus 1 e to the negative x dx. So on this one, again, it has numbers here, but we're not doing those right yet. So just find the antiderivative of this. I notice that if I let this be u, first time I do integration by parts, it's going to come down to like a 2x. If I do integration by parts one more time, it's going to come down to a number, and so that's good. This one's just going to cycle back and forth. So 2 applications of integration by parts should work here. U is equal to x squared plus 1. du is 2x dx. The dv was the only thing I really had left, which was this. Integrate up, just be careful with that negative sign, negative e to the negative x. And so this becomes ultraviolet, this times this. I'll bring the negative way out front. Minus integral voodoo. So let's see what happens here. I have another negative, and I have a 2, so it's going to come out as a plus 2 out of my integral. And then I'll still have the x, then e to the negative x dx. So I'll do integration by parts again on just that part, just the integral, right, not the 2. So u is equal to just the x, du is dx, that's what I wanted. My dv was e to the negative x dx. That means v is equal to negative e to the negative x. And so this becomes equal to negative x squared plus 1 e to the negative x plus 2 times in brackets ultraviolet minus voodoo, negative x e to the negative x, that's ultraviolet, this times this, minus integral voodoo. Let's see, do I have a negative here? Negative and positive, so negative will come out, turn it into a plus, and the only thing there is e to the negative x dx. And I'm going to distribute a 2 through, but the antiderivative of this, right, the antiderivative, we can just do this mentally. We've done it twice already, so negative e to the negative x, no more integral sign, we'll have a plus c. So our answer is negative x squared plus 1 e to the negative x. 2 goes through here, negative 2x e to the negative x. 2 goes to here, right? So negative 2 e to the negative x, and I need to erase that. E to the negative x, and then plus c. That's it. You could factor out an e to the negative x again if you want, but just leave it like that. Actually, it might work out pretty nice if you factor out an e to the negative x. Let's do that just to see it. If I factor out an e to the negative x, I'll be left with this right here, negative x squared plus 1. This right here, negative 2x. And this right here, negative 2. And then plus some constant. And this is just a quadratic e to the negative x. This is negative x squared. And then we have minus 1, but then minus 2, so minus 3. And then in the middle, negative 2x plus c. And then you can also factor a negative out of this if you wanted to, but that's good enough for now. All right, what is it? 19, I'm on 19, let me get a little. Whoa. Okay. What am I on, 19? Man, we've done so many of these. These are so similar to what we've already done. All right, but I'm going to do it. 19, integral, see, r cubed natural log r cubed natural log r dr. You're doing on time there, 40 minutes. All right, so we did one very, very similar to this. It was actually number 10. So we see the natural log r, we know derivative, that's 1 over r. We can integrate this. It'll just be a power of r, and then those two will go together, and they should become something very nice. So u is going to be equal to the natural log r. dv is going to be r cubed dr. Du is 1 over r dr. And then the antiderivative of this is 1/4 r to the 4th. So we have ultraviolet, 1/4 r to the 4th times natural log r minus integral voodoo, which is cross. Notice that 1/4 can come out. When you do r to the 4th and you divide by r, you get r cubed. So r cubed dr. Antiderivative of this is 1/4 r to the 4th, and we hit that 1/4 out here again. So we get 1/16 out there. R to the 4th plus c. So I did this one already, just integrated it. Power rule. That's it. Number 20. All right, again, it has numbers. We're going to ignore those. Natural log y over square root y dy. All right. Well, I know that if I take u to be the natural log of y, the derivative is 1 over y, which is a power of y. And I know that this is a power of y, so if I integrate this, I'll have another power of y. And so when I put them together, I should have some power of y. So let me try this. U is equal to natural log y. Du is equal to 1 over y dy. dv is equal to 1 over root y dy. Now be careful, because what that means, we need to integrate that. Hold on just a second. So this is going to be integral y to the negative 1/2 dy. So we use our rule, we add 1 to this, which is 1/2, 1 over 1/2 in the front, so that's 2. So this is going to be 2 y to the 1/2, 2 square roots of y. So that's what this is. I'm going to actually write it as v is equal to 2y to the 1/2. And now, what the heck was that? Now we can write our ultraviolet minus voodoo. So ultraviolet is this times this, so 2 this, okay, I'll write square root of y and then natural log y, that's this times this, and then minus integral, and notice I have a 2 here, so I'll pull that out. And then I have y to the 1/2 over y to the 1/2 over y, which is the same as 1 over y to the 1/2, which is y to the negative 1/2. So this is y to the negative 1/2 dy. So see, that's what I meant. We were going to have a power of y left. So there it is. And now we just integrate that. So this is equal to 2 square root of y, natural log y, minus 2 times, let me give myself a space here, y, let me see, I add 1 to that, I get 1/2, and I do 1 over 1/2, which is going to be 2, so another 2 there, plus some constant. So final, 2 square root of y, natural log y, minus 4 square root of y, plus c, and you could at this point factor out a square root of y and a 2 if you want. Okay, I'm going to stop this real quick, come back, I've done the first 20.